Warning: the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This video is meant as a review of concepts from your trig class. As such, I don't delve into the proofs of theorems, nor do I go into excruciating detail with examples. If you've never had a full course in trig, you're currently in a pre-cal course, I highly recommend watching my trigonometry playlist on YouTube, as it goes into greater detail with all of trigonometry. Again, trig is so very important for calculus that having a shaky background in the subject will lead to abysmal results in calculus. All right, let's jump into this review of applications of right triangle trigonometry. The part one, by the way, is there just to let you know that we're not going to find angles here. We're just going to find side lengths. Finding angles requires inverse trigonometric functions, which is not part of this review. All right. An airplane is flying at an elevation of 7,300 feet, directly above a straight highway. Two motorists are driving cars on the highway on opposite sides of the plane, and the angle of depression, that is going to be a very important phrase in all of trigonometry. So the angle of depression to one car is 38 degrees, and the angle of depression to the other car is 62 degrees. How far apart are these cars? Let's draw a picture of this situation. So we've read the problem, and after you read the problem, you really want to try to understand what's going on. So the best way to understand this is to draw a picture. And there's my terrible picture right there. And to give you an idea of, oh, by the way, these are two different cars on the roadway. I'm going to call the cars car A and car B, just because you can see by my handiwork up above, I am not an artist. So there we go. The angle of depression, what does that mean? Well, you're a passenger on this terrible looking airplane, and you're looking out the window and you look down. The angle with which you're looking down from the horizontal, so this is the horizontal right here, the angle with which you look down is called the angle of depression. And so that is 38 degrees in this direction. When you look forward and then down at the second car, you're looking down at a steeper angle, which is a 62 degree angle. And the other piece of information we have here is that the airplane is at an elevation of 7,300 feet. So I'm going to go ahead and just draw in an altitude here. I'll just dash it out. That's our altitude. It makes a right triangle with the ground, or I should say a right angle with the ground. So here's a right angle, and it's a right angle obviously in both sides. And this is going to help out because your prerequisite before going into trigonometry was actually geometry. And from geometry, we know if we have two parallel lines, and by the way, let me go ahead and bring up my ruler again. This line right here in green is parallel to the ground. Your horizontal view is parallel to the horizontal ground. And if you have two horizontal lines and they are there's a transversal or a line that connects them, the alternate interior angles must be the same. So these two angles right here must be 38 degrees. 38 and 38, alternate interior angles. And then same thing on the other side. This will be 62 degrees because, again, alternate interior angles. So this is going to help out immensely. We want to know what the distance is between car A and car B. We also know that that black vertical length is 7,300 feet. 7,300 feet. And this breaks the world into two different triangles. We have the triangle I'll highlight here. And then we have the rightmost triangle, which is this guy right here. And we can find the floor lengths of those. do that in blue. Actually, this floor length right here I can find, and this floor length right here I can find. And I'll call this D sub 1 for distance 1 and D sub 2 for distance 2. Now, in the yellow highlighted triangle, what trig function relates the known information to the unknown information? The known information is 38 degrees, 7,300 feet, and the unknown information is at D sub 1. Well, the trig function that relates all this information is, that's opposite, that's adjacent, so it must be the tangent. And if you watched the previous video, we had the tangent also being used there. It just is the case that, for applications, it is often that the trig function that gets used is a tangent. It's not always the case, but it often is. So there's our relationship between the knowns and the unknowns. I'm going to multiply both sides by D sub 1 and divide both sides by the tangent of 38 degrees. So we get that D sub 1 is 7,300 feet divided by the tangent of 38 degrees. And we can grab a calculator for that. The other one, again, what relates this known information to the unknown information? Well, that again is opposite over adjacent. And so therefore, again, we have tangent, this time of 62 degrees, is equal to the 7,300. Did I say 71 earlier? If I did, I meant 7,300. 7,300, just double check, yeah. Feet divided by D sub 2. And therefore, D sub 2 is equal to 7,300 feet over the tangent of 62 degrees. And then you would add up D sub 1 and D sub 2 to find the total distance between these two vehicles. Now I'm going to, instead of hopping over to Desmos to do it, I'm just going to quickly do it right here. And I get that the distance between the vehicles is approximately 13,225 feet, a little over 2 miles apart from each other. All right, so that's a good application, and it kind of reminds us of the angle of depression. There's also an angle of elevation. We'll see that in the next application. Now, this is a good real application that I actually used, with the exception of the last part about the price. I had to have a tree cut down on my property, and when I had people come out to give quotes, one person had told me, well, it's going to be kind of expensive if it's a tall tree for us to cut it down. Do you know how tall the tree is? Now, I'm pretty terrible at eyeballing how tall something is, but I do have ways to measure angles. And so I used a way to measure angles, and I stood a specific distance away from the tree, specifically 42 feet away from the tree, on an upslope of a hill, and I measured the angle of depression to the bottom of the tree and the angle of elevation to the top of the tree. And this is what I got. So I was 42 feet directed distance away from the tree on an upslope of a hill. The angle of depression to the base of the tree was 8.1 degrees, and the angle of elevation at the top of the tree is about 60.4 degrees. And really, honestly, it was more like just 8 degrees and 60 degrees, but whatever. If the crew who came out to cut down the tree charges $300 plus $80 per 10-foot section, how much will I have to spend to get this tree cut down? So let's draw a picture of this situation. All right, so this is what it looks like. I have a big old tall tree there, and I stood 42 feet away. I should probably have drawn that in. There we go. So this directed distance to the tree itself was 42 feet. And then what I did is I measured the angle of depression, and that angle of depression was, and let me use blue for this. This was an 8.1 degree angle. And the angle of elevation, again, angles of depression and elevation are from the horizontal. So you're looking horizontally here directly at the tree, and you look down through an angle of 8.1 degrees. That's an angle of depression. And when you look up through an angle of 60.4 degrees, that's an angle of elevation. And we want to know what is the height of the tree because, well, that's how it's going to cost a lot if it's a really tall tree. So the question is, what is this total height? But I can break up the total height into two pieces, which I'm going to do. A first height and then this second height, because there are two triangles. Just like in the previous problem, there were two right triangles. We have two right triangles here. We have a smaller triangle, which I'll just highlight in here. It's this guy right here. So this blue triangle, if you will. And then we have a larger triangle, which I'll highlight in yellow. So this larger triangle right here is going to be the other one. And let me zoom out a little bit. Good enough for me. So we have those two right triangles, and we want to know what is the overall height of this tree. Again, using all of the older information, I'll start with the blue triangle here. What is the trig function that relates this angle to these two sides? And again, it's going to be the tangent. It's very rare that it's anything other than the tangent for applications, because if you knew what the hypotenuse length was, then you would have like a string connecting the base of the tree to my eyeball and a string connecting the top of the tree to my eyeball, which is not going to happen because I can't reach the top of the tree. So I could have done the hypotenuse though for the floor. I could have attached a string to the bottom of the tree and measured that distance to my head, but I just didn't. So let's see. We know that the tangent of 8.1 degrees is opposite over adjacent. So that'll tell us that H1, the first height, is 42 tangent of 8.1 degrees. And then the second height, again, same idea. The trig function that relates that angle to that side to this side is going to be, again, the tangent. So we know the tangent of 60.4 degrees is equal to H sub 2 over 42. And that implies that H sub 2 is going to be 42 tangent of 60.4 degrees. And you would add H1 to H2. And I'll just pause and do that. And I'm going to round to the nearest whole number because there's a lot of literal eyeballing here. This is going to roughly be 80. So the total height, H1 plus H2, is approximately 80. It's 79.9, but I'm just going to say 80 feet. Now, the people who are going to cut down the tree charge $300 plus $80 per 10-foot section. So the total cost, I bet you forgot about that, right? The total cost is equal to $300 plus we have 8 10-foot sections, so it's 8 times $80. That's supposed to be a dollar sign. Didn't quite work out for me. It's $640. That's $940, which is almost what it cost, honestly. So there you go. All right. For some reason, my eraser is not working, so I'll do this. There we go. $940. All right. So that's a review of right triangle applications.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.